I'm going to start with the Chapter 9 review. We're on page 250. Now, please, 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 everyone, right now, take out a notebook. I don't care if it's just a random loose leaf sheet of paper, something that you can keep so you can work out this problem. Okay, so we're on number 22 on page 250. Okay, so 22, and we're going to just start with letter A. Okay, so we're working on 22A. This is the chemical reaction that we're going to be looking at. Okay, really important that whenever you work through any problem, you write down the chemical reaction first. Okay, leave it up there as a template for you so that you can always refer back to it. I'm going to go ahead and start recording. Okay. Oh, I think I already did, right? 1 second. Yes, we are recording. Okay, good. All right, so we're in number 22. Basically, let's read it out, okay? Hematite, which is Fe2O3, is converted to molten iron in a blast furnace and is then poured into molds. The balanced equation is the following, okay? Fe2O3, which is a solid. I didn't go ahead and write that down there. When we're doing these problems, you can write them down. They are kind of important. But if the equation is already balanced, you don't really need to worry about them too much, especially if you're like short on space, okay? You don't need to write the states. Plus 3CO gas is converted into 2Fe, so 2 irons, and 3CO2 gas, okay? What we need to find out is how many moles of Fe2O3 must react to produce 262 moles of Fe. So the first thing we want to do with these problems always is find out what we're starting with and what we want to finish with. Okay, normally what we're starting with is whatever the problem gives us. Okay, so Camille, what are we starting with? What is the problem giving to us?
The equation.
Okay, so it gives us the equation, but I'm talking about specifically letter A. What is pretty much the only value that it gives us?
262 moles.
Yeah, exactly, right? So that's kind of like a dead giveaway. Sometimes you'll have multiple things, but for the most part, it's just going to be one thing that they give you. So they're giving you 262 moles, okay? 262 moles of what? Of Fe, of iron, okay? And now you want to finish with how many moles of FeO3, okay? So basically, moles of FeO3, and it is Fe2O3. Okay, so now let's look at this because here's where we can get confused, okay? Here I put start and I put finish. But if you look at the equation, we start with Fe2O3 and it then degrades into Fe, okay? So it's important that you know that just because I'm saying start and finish, I'm not referring to the equation itself. I'm not referring to the chemical reaction, but I'm referring to the problem, okay? When I mean problem, I mean, what do they want to know? Basically, summed up, what they want to know is how many moles of Fe2O3 are needed to be able to produce 262 moles of Fe. So we're kind of working backwards, kind of using deductive reasoning to find out, hey, I was able to get 262 moles of iron. How many moles of this did I need? Okay, and the name of that molecule is hematite. Okay, so let's try to keep that in mind as we try to solve these problems. Now, basically, if you guys remember, when we were dealing with conversions, we would use this a lot. Okay, we would use this little template to kind of go back and forth from atoms to moles to mass to moles to atoms, depending on whatever it was. But here's when we were just dealing with one type of atom, one molecule. Okay, now we're dealing with multiple molecules. We're trying to figure out how can I know how much of this I need when I'm producing this. Okay, so this is not gonna cut it. All right, because here is we're just converting between one type of molecule or one type of atom. All right, what we need to do is we need to figure out how many moles of this is needed to produce this, right? So the way that we do that is by using the mole to mole ratio. Okay, basically, if you guys remember from yesterday, so someone just joined. Who was that? Was that Chris? Hey, Chris, how are you? Okay. Basically, if you guys remember from yesterday, those of you that were on, and if not, you can watch the video, we always need to do a jump, okay? Because we start with 1 mole from one molecule, right? Or we start with grams from one molecule, and we need to be able to jump into moles or grams of a different molecule, okay? And the best way to remember to do that is to set up the bridge notation, know what you want to start with, and know what you want to finish with, okay? So let's set up our bridge. We don't know exactly how many columns we're going to have, so we're going to just break it down first, okay? We're starting with moles of Fe, okay? And we want to finish with moles of FeO2. So let's write that down, moles of Fe2O3. That's what we want to finish with, right? And we know that we're starting with 262 moles of Fe. And that so far is all that we know, okay? Now remember that whatever you start with, you always want to put it over 1. Okay, now we need to know how many columns are going to be in our bridge, 1, and also what is the thing that we're going to put in our bridge. It could be multiple things. If you saw the video yesterday, we had bridge with 3 columns, 4 different spaces. This problem is actually a little bit more simple, okay? If you're trying to find out, and there's a couple of different types of problems, you can go from either grams of one molecule all the way to grams of another molecule. So grams of molecule 2. Okay, and I don't know if you guys can see that. Can you guys see that? Move my face here. Okay, so if you have grams of molecule 1, you can go to grams of molecule 2, but you have to pass through a couple of steps. Okay, and I'm gonna go ahead, and I think it's just these 2 columns. No, let's do 3. So if you're going to go from grams of one molecule to grams of a different molecule, you always need to go back to the mole, okay? And thankfully in this problem, we're not going from grams of this to grams of this, right? We're just going from moles of this to moles of this, okay? Basically, what you would need to do here is go from moles, here, we would do from moles of 1, and it would convert into moles of 2, and then you can go to grams. Now, I know this sounds like a little bit weird. Just keep this in the back of your head, and we will do a problem where this works out, okay? But basically, what you need to know right now is that whenever you start with a mole of a molecule, and you want to finish with a mole of a different molecule, you're going to need to use the mole-to-mole ratio from the equation, okay? So this problem's easier than the problems that we were doing yesterday. If you were on the call yesterday, if you didn't, or if you saw it on the video, then this should be simple for you, okay? Basically, we want to go from moles of this to moles of this. And the best way to do that, the only way to do that, is by using the mole-to-mole ratio. Okay, who just joined now? Brian, and who else?
I'm me, sir.
And Matthew? Okay.
Yeah.
Anyone else that I have not gotten so far? Abby? Okay.
Yes.
Okay, cool. All right, so we want to go from moles of this, right? Moles of iron to moles of this. We're going to need to use the mole-to-mole ratio. How do we find the mole-to-mole ratio? We just have to look at the chemical equation, okay?
Yeah.
Basically, how many moles of iron are produced per mole of Fe2O3? We have 1 mole of Fe2O3 and 2 moles of iron, okay? And that's what we're gonna use right here so that we can cancel out moles of Fe. We're gonna use it as a ratio so we can cancel out moles of Fe and make the jump this way into moles of Fe2O3. And this is how you do it. You write the moles of Fe2O3 is gonna be 1 mole of Fe2O3 per 2 moles of Fe. How do I know that? The only thing I have to do, guys, is look at the coefficients in front of the molecules or in front of the atoms in the chemical equation, okay? So to make that jump from one molecule to another, you need to use the mole-to-mole ratio. Just so you know, in almost every single stoichiometry problem that you're going to have, you're going to do that jump with the mole-to-mole ratio. So it's super important, one, that your equation is balanced, right? And if not, you have to balance it first. But for the most part, it will tell you if the equation is balanced or not. In this case, the equation is balanced. So you know right off the bat that 2 moles of Fe are products of 1 mole of Fe2O3, okay? Why do we put moles of Fe2O3 on the top? Because that's what we want to finish with, okay? And we put moles of Fe on the bottom because we want to cancel that, okay? Always, always, always make sure that you cancel it out so you know that what you're finishing with is the moles of what you want, okay? We know we want moles of Fe2O3. That's what's gonna take place right here. And we're just gonna go ahead and work it out in our calculators now. So I need you guys to give me a second because I don't have my calculator. I'm just gonna go ahead and use my phone for this problem at least. And then I'll go get my calculator and we can work it out. So let me just put my phone on here. All right, so we have 262 moles of iron, right? We canceled out the unit, right? Remember, we only cancel out the unit. We don't cancel out the actual number. So basically, you're just going to write it out. And I think the best way to do it is to just pretend that there's a little person here. And that person is walking across the bridge until it gets to its destination, which is right here. Okay, so this bridge has 1 column suspended by 1 column. You have 262, right? And now there's a 1 at the top. So you could multiply by 1, but really the only thing that you need to do is make sure that you are dividing by 2, okay? Anything that's at the top is getting multiplied. Anything that's at the bottom is getting divided, okay? So you have 262 basically divided by 2, and what that's going to give you is going to give you 131 moles of Fe2O3, okay? And that 131 moles of Fe2O3 has to now be converted into what, Matthew? The proper what? Our final answer can only have how many of what? 3 significant digits, right? Okay.
Yeah.
Why don't we use these right here to, why don't we just use like 1 significant digit? Because we have 2 things here that have a significant digit. Just 1 significant.
Because it's what we start with?
It's what we start with, exactly, right? This is a conversion factor. So we don't use this when we're talking about significant digits. Thankfully, our answer has only 3 significant digits. So our final answer is going to be 131 moles of Fe2O3. Now, what did we just answer? Because it's super important that we know what we're answering, okay? Basically, the question asks, how many moles of Fe2O3 must react to produce 262 moles of Fe, okay? So this is the amount of moles that need to be present in this reaction at the beginning to produce 262 moles of Fe. And if you think about it, it makes sense because for every mole of Fe2O3, you're producing 2 moles of Fe. So if you start with 131 moles of Fe2O3, you're going to have to finish with double that amount, right? Which is 262 moles of Fe. Okay? So that's the first question that we worked out. Are there any questions over this? Any questions? No? Okay, good. So we're going to go ahead and move on. What I'm going to do, I'm going to pause the video real quick. You guys can take like a short break. I'm going to stop the recording actually for a second, just so that I can have them differently, so I don't take up too much space, okay? And I do need to go get my calculator. So I'm going to stop the sharing. I'm going to stop the recording for a second. And all right, so we're going to continue now on question 22. Can you guys see me and also see the paper? Yeah?
Yes.
Yes? Okay, good. All right, so let's get to it. We're on question 22. Let's do letter B. Okay, so 22B. We're still using this equation. Okay, so just go ahead and whenever you write this equation down, box it, okay, so you can keep it, so you know that you're going to be using that equation every single time. Okay, so the answer to 22A was 131 moles of Fe2O3. Let's go ahead and move on to letter B. We always start by figuring out what we're starting with and what we're finishing with. Okay, so I'm gonna ask someone's help now. Ethan, I'm gonna read 22B, and I want you to tell me what we're starting with. How many moles of carbon dioxide are produced by the reaction of 64.0 moles of CO, of carbon monoxide? What are we starting with?
64.0 moles of CO.
There we go, perfect. 64.0 moles of CO. And that's super important because moles, we can just make the jump right away. Okay, we don't need to go to grams. Okay, we're just going from mole to mole. What are we finishing with? Ethan.
Moles of CO2.
Moles of CO2, exactly, right? And do we know how many moles of CO2 yet?
Nah.
No, we don't. Okay, that's what we're going to try to figure out. Okay, so when we set up our bridge, we know we're going from moles to moles, so we know it's just going to be one column. Okay, by the way, this meeting's going to end in 10 minutes because nothing good comes free. So as soon as we finish this problem, we're going to stop this meeting. We're going to take a short, like 5-minute break. I'll put up the link for the new meeting, and then you guys will sign into that meeting. Okay. So we start with 64 moles. Let's go ahead and do this and that. Let's put what we're starting with. So everyone do this in your notes. 64.0 moles of carbon monoxide, okay, over 1. Now, we want to finish with, what are we trying to finish with?
The CO2.
Moles of CO2, exactly. Are we going to grams? No, we're just going from mole of one to mole of the other, okay? So it's just going to be one conversion. Now the conversion factor that we're going to be using is going to be what, Brian? What do we call that? What we put here to go from moles of one to moles of the other?
Multiple ratio.
Yeah, the mole to mole ratio, exactly. Okay, that's what we're going to write here. Mole to mole ratio. And what is the mole to mole ratio, Brian, of CO2 to CO? And which one goes on top?
3 or 3.
Yeah, exactly. So there are 3 to 3. Which one goes on the top? The moles of which one?
CO.
Of not CO, because we want to finish with CO2, right? And whatever we finish with is whatever we're going to put on top, or whatever the next thing we want to be is whatever we put on top. And we put CO on the bottom because this needs to cancel out.
Oh, to cancel out.
Exactly. So first thing you do before you do the operation is make sure that your units can cancel out, okay? So here we have mole of CO canceling out with mole of CO. So we're good. Let's double check the mole to mole ratio. 3 moles of CO2 are produced from 3 moles of CO. So we did that correctly, okay? Now what's the next step? We know that we're going to finish with moles of CO2, so what do we have to do?
Walk along the bridge. Cancel
Yeah,
and multiply.
walk along the bridge, exactly. So we're here, okay? We're going to walk along the bridge. What's the first thing we run into, Matthew?
64 times 3?
Yeah.
Or no,
So we
yeah.
can do, so we can tackle this a couple of different ways, right? We can realize that 3 over 3 is just 1 and then just finish with 64. Or we could just do the whole thing, 64 times 3 divided by 3, right? We multiply the top, divide the bottom, and what are we going to end up with? Just 64. Exactly what we started with, right? Okay, so we end up with 64.0 moles of CO2. Now let's think about this. Does this make sense before we check for significant digits? Does it make sense that if you start with 64 moles of carbon dioxide, you're going to finish with 64 moles of carbon monoxide, you're going to finish with 64 moles of carbon dioxide? Does that make sense? Did we make a mistake?
No.
No? Why did we not make a mistake, and why does it make sense, Matthew?
Because the mole to mole ratio is 3 to 3 of 3. It's
Exactly,
like,
right? So for every 3 moles of carbon dioxide, you're going to have 3 moles of, for every 3 moles of carbon monoxide, you're going to have 3 moles of carbon dioxide, right? So that means for every 64 moles of carbon monoxide, you're going to have 64 moles of carbon dioxide, okay? So it's going to be exactly the same, all right? So let's check significant digits. Let's see who is on. Chris, can you hear me? Can you turn your mic on? Let's see. All right, maybe
Chris
not.
is mute.
Chris is not on, right? He was on. Ooh, gotta take his name off. Okay. Let's see. David. David, how many significant digits do I have in the beginning?
The beginning. What do you mean?
This right here.
64. Okay. You have 3.
3. Exactly. 3. Okay. 3 significant digits. How many significant digits do I have here?
1.
1 in each, right? But does it matter?
No.
No, it doesn't, because it's a conversion factor. Remember, we don't take significant digits into account with conversion factors, okay? So how many significant digits can I have in my answer?
3.
3. So what's my final answer?
64.0.
Yeah, exactly.
Moles of
64.0
carbon.
moles
CO2.
of carbon dioxide. Okay, that is 22B. Okay, let's do this. In this break that we're taking, I want you guys to answer 22C on your own. Okay, I'll get you guys started. So I'll go ahead and I'll tell you what to start with, what to finish with, and I want you guys to do everything and give me a solid final answer for 22C. Okay, we have 4 minutes and 20 seconds left on this call. How many moles of Fe2O3 must react to produce 760 kilograms of Fe? So this is a little bit different, okay? Because if you notice, we're not just going from moles to moles anymore, okay? We're going from what? What are we starting with now? Let's see, Camille, what are we starting with? What are we starting with? What's the
Kilograms.
value that we're given?
Okay, 760 kilograms
Exactly, 760 kilograms of what?
of Fe.
Of Fe, okay? And what are we finishing with? Now remember, this doesn't mean that the reaction takes place in this way, right? This is what the problem is asking us. And what are we finishing with? What are we trying to figure out?
Moles of Fe2O3.
Exactly. So moles of Fe2O3. Okay, so let's think about this now. This is asking us how many moles of Fe2O3 are needed to produce 760 kilograms of Fe. When we write it out in our bridge notation, we're still going to write it out with this first. Just understand that this is just asking something that kind of is going backwards in the actual reaction. Okay, so to set up the bridge, you would have to think about what you're starting with. You're going to start with kilograms of this, right? But right off the bat, do we measure moles and atomic masses basically in kilograms? What do we measure that in?
No, we measured in grams.
In grams. So first thing you have to do is convert this to grams, okay? Once you get that, you're going to have to set it up, and it's going to have 2 columns actually, okay? And just so you know, we're going to go from grams of Fe, right, into what? What's the next step before we can make that jump?
We have to convert it. So you
Into-
put 1,000 on the bottom, right?
Yeah, you're gonna divide it by 1,000. No, you're gonna multiply it by 1,000, right? Because kilograms is a bigger unit. Therefore, you're gonna have to have a smaller number. Okay. Convert this kilograms to grams, right? Then you're gonna go from grams of Fe to moles of Fe, then from moles of Fe to moles of Fe2O3. Okay. So it's gonna have 2 columns, your bridge. Okay. It's about to cut us off. Okay. Take this next 5 minutes to answer this question. Okay, I'm gonna I'm going to make a new Zoom call, and then I'll see you guys there in 5 minutes, exactly 5 minutes. Okay, so at 43. All right?
All right.
All right, guys. See you soon.